While 40% seal-offs may appear identical to 25% seal-offs, subtle differences exist. The main difference is the size of the opening in the seal-off. A 40% seal-off has a larger opening, allowing for more cables to pass through. This increased opening means that a 40% seal-off can accommodate more cables compared to a 25% seal-off, providing greater flexibility in cable management. Furthermore, 40% seal-offs have undergone rigorous testing and are listed by the Underwriters Laboratories, or ALL, as meeting specific standards. These standards ensure that the seal-offs provide adequate protection against the ingress of moisture, dust, and other contaminants. Despite the functional differences, 40% seal-offs often appear visually similar to 25% seal-offs. Subtle visual cues may indicate a 40% seal-off. Firstly, 40% seal-off should be clearly labeled as such by the manufacturer, either in the body of the seal-off or on its packaging. Secondly, 40% seal-offs may be slightly larger than 25% seal-offs due to the increased opening size. 40% seal-offs are typically used in applications where a larger number of cables need to be accommodated. They offer greater flexibility and convenience in cable management compared to 25% seal-offs. It is important to verify the compatibility of these seal-offs with the specific enclosure or system being used. Understanding the differences in appropriate applications of 25% and 40% seal-offs is crucial for ensuring electrical safety and compliance with the National Electrical Code, or NEC. Seal-offs are used in hazardous locations to prevent explosions. The NEC provides guidelines on the proper installation and usage of seal-offs. The specific NEC articles and sections relevant to seal-offs depend on the application and location, but generally, Article 500 through Article 516 address hazardous locations. Seal-offs are designed to prevent the passage of gases, vapors, or flames from one portion of an electrical system to another. This is particularly important in areas where flammable substances may be present. The percentage rating of a seal-off, such as 25% or 40%, refers to the full capacity of the sealing compound within the fitting. 40% seal-off allows for a greater volume of sealing compound, which may be necessary when dealing with a larger number of conductors or larger conduit sizes. When selecting a seal-off, it is essential to consider the specific requirements of the installation, including the type of hazardous location, the size and number of conductors, and the conduit size. Always refer to the manufacturer's instructions and the NEC for detailed guidance on proper installation and usage. The UL listing of a seal-off indicates that it has been tested and certified to meet specific safety standards. This listing provides assurance that the seal-off will perform as intended and provide the necessary protection in hazardous locations. In addition to the percentage rating, seal-offs are also available in various sizes to accommodate different conduit sizes. The conduit size must be compatible with the seal-off size to ensure a proper seal. Seal-offs are typically installed at specific locations within the conduit system, such as at the entrance to enclosures or at boundaries between hazardous and non-hazardous locations. The NEC specifies the required locations for seal-offs based on the type of hazardous location and the potential for the transmission of flammable substances. Proper installation of seal-offs is crucial for their effective operation. This includes ensuring that the sealing compound is properly mixed and applied, and that the seal-off is securely connected to the conduit system. Regular inspection and maintenance of seal-offs are also important to ensure that they continue to provide the necessary protection. This includes checking for any signs of damage or deterioration and replacing the seal-off if necessary. The NEC provides detailed requirements for the inspection and maintenance of electrical equipment in hazardous locations, including seal-offs. Failure to properly install and maintain seal-offs can result in serious consequences, including explosions and fires. Therefore, it is essential to follow all applicable codes and standards when working with seal-offs. When selecting a seal-off, it is also important to consider the environmental conditions in which it will be used. Some seal-offs are designed for use in specific temperature ranges or in corrosive environments. The manufacturer's specification should be consulted to ensure that the seal-off is suitable for the intended application. In addition to preventing the passage of flammable substances, seal-offs can also provide protection against moisture and dust. This is particularly important in harsh environments where these contaminants can damage electrical equipment. Seal-offs are typically made of durable materials such as cast iron or aluminum, which provide resistance to corrosion and physical damage. The NEC requires that seal-offs be properly grounded to ensure electrical safety. This grounding helps to prevent the buildup of static electricity, which can be a source of ignition in hazardous locations. When working with seal-offs, it is important to use appropriate tools and equipment. This includes using a conduit reamer to remove any burrs or sharp edges from the conduit, and using a torque wrench to tighten the seal-off to the manufacturer's specified torque. The NEC also provides requirements for the training and qualification of personnel who work with electrical equipment in hazardous locations. This training ensures that personnel have the necessary knowledge and skills to safely install and maintain seal-offs and other electrical equipment. In addition to the requirements for seal-offs, the NEC also provides requirements for other types of explosion-proof equipment, such as lighting fixtures and motors. All electrical equipment used in hazardous locations must be properly rated and installed to prevent explosions and fires. The NEC is a comprehensive document that provides detailed guidance on all aspects of electrical safety in hazardous locations. It is essential for anyone who works with electrical equipment in these locations to be familiar with NEC requirements. The use of 40% seal-offs can provide several advantages in certain applications. Firstly, they allow for a greater number of conductors to be installed in a single conduit run, which can reduce the overall cost of the installation. Secondly, they can simplify the installation process by reducing the number of conduit runs required. Thirdly, they can improve the reliability of the electrical system by reducing the number of potential points of failure. However, it is important to carefully consider the specific requirements of the installation before using 40% seal-offs. The NEC and the manufacturer's instructions should be consulted to ensure that the seal-offs are properly installed and used. The proper selection and installation of seal-offs are critical for ensuring electrical safety in hazardous locations. By understanding the differences between 25% and 40% seal-offs, and by following all applicable codes and standards, it is possible to prevent explosions and fires and protect people and property. When dealing with seal-offs, it is crucial to consider the specific hazardous location classification. Hazardous locations are classified based on the type of hazardous material present and the likelihood of its presence in ignitable concentrations. The NEC defines different classes, divisions, and groups of hazardous locations, each with specific requirements for electrical equipment. Seal-offs are typically required at the boundaries between different classes or divisions of hazardous locations, or at the entrance to enclosures containing electrical equipment that could be a source of ignition. The specific requirements for seal-offs in each type of hazardous location are detailed in the NEC. In addition to the NEC, other standards and regulations may also apply to the installation of seal-offs. These may include local building codes, fire codes, and insurance requirements. It is important to be aware of all applicable codes and standards before beginning any electrical work in hazardous locations. Proper documentation is also essential when working with seal-offs. This includes maintaining records of the seal-off type, size, location, and installation date. This documentation can be helpful for future inspections and maintenance. The use of seal-offs is just one aspect of a comprehensive approach to electrical safety in hazardous locations. Other important measures include proper grounding, bonding, and overcurrent protection. All of these measures work together to prevent explosions and fires and protect people and property. It's also important to note that the term seal-off can sometimes be used interchangeably with conduit seal. While the terms are often used to describe the same type of fitting, it's helpful to understand that conduit seal is a more general term that encompasses a broader range of sealing methods used in conduit systems. Seal-offs specifically are designed and listed for hazardous locations, while other types of conduit seals may be used in non-hazardous locations to prevent the ingress of moisture, dust, or other contaminants. The selection of the appropriate type of conduit seal depends on the specific application and the environmental conditions. In some cases, a simple threaded connection with sealant may be sufficient, while in other cases, a more robust seal-off fitting is required. Regardless of the type of conduit seal used, it's important to ensure that it is properly installed and maintained to provide the necessary protection. Seal-offs are not a substitute for proper wiring practices. All electrical wiring in hazardous locations must be installed in accordance with the NEC and other applicable codes and standards. This includes using the correct type of wire, properly terminating connections, and providing adequate overcurrent protection. Seal-offs are just one component of a complete electrical system, and they must be used in conjunction with other safety measures to ensure the overall safety of the installation. It is also important to consider the potential for mechanical damage to seal-offs. Seal-offs are typically installed in exposed locations where they can be subject to impact or abrasion. If a seal-off is damaged, it may no longer provide the necessary protection and it should be replaced immediately. The NEC provides requirements for the protection of electrical equipment from physical damage, and these requirements should be followed when installing seal-offs. In some cases, it may be necessary to provide additional protection, such as a guard or barrier, to prevent damage to the seal-off. When replacing a seal-off, it is important to use a replacement that is of the same type and rating as the original. Using an incorrect replacement can compromise the safety of the electrical system. The manufacturer's instructions should be consulted to ensure that the correct replacement is used. It is also important to properly dispose of old seal-offs. Seal-offs may contain hazardous materials such as lead, and they should be disposed of in accordance with all applicable regulations. Contact your local waste management authority for information on proper disposal methods. The use of seal-offs is a critical aspect of electrical safety in hazardous locations. By understanding the differences between 25% and 40% seal-offs, and by following all applicable codes and standards, it is possible to prevent explosions and fires and protect people and property. In summary, remember firstly, the opening size is the key differentiator, with 40% seal-offs having a larger opening to accommodate more cables. Secondly, UL listing ensures that 40% seal-offs meet rigorous safety standards for protection against environmental contaminants. Thirdly, pay attention to labeling and potential slight size differences as visual cues to identify 40% seal-offs. Finally, verify compatibility with your specific enclosure or system.